See, in this, how to make field flux a bit better sinusoid or to reduce harmonics. If you see, for example, there are two types of rotors. One is cylindrical rotor, another one is salient rotor. Okay, basically we decided that in rotor, rotating part, field should be there in our first session. Now in cylindrical rotor, how to do, in salient rotor, how to do? Yes, actually questions cannot come from here, problems cannot come from here. Let me cover up very soon. Okay, if it is cylindrical rotor, okay, in cylindrical rotor, for example, if I have two slots here, okay, so this is going to be A, this is going to be one conductor, this is going to be another conductor, and this is rotor. Okay, if I supply, for example, dot cross of DC current, because field current should be DC current. If I supply DC current, my MMF is going to be cross dot. MMF is going to be in this direction, so this is going to be N pole, this is going to be S pole. Okay, now see, if I cut it and keep it here, okay, this is dot conductor current, and this is going to be cross, and you are injecting DC current here, okay. Now if you are injecting DC current, what is MMF or Ampere's law? Closed integral H dot dl equal to net amount of current. You need not remember this formula here. If I use any formula without much explanation, means that it is not required. Okay, don't bother much. I net is nothing but net amount of current enclosed in a closed path is nothing but MMF. Okay, what is what do you say, closed path? For example, if I take closed path, how much is the current? I net amount of current in a closed path is going to be I field current. Okay, and see, from here to here, if I take closed path, how much is the current enclosed? Same. How much is the current enclosed? Same. How much is the current enclosed? 0. Okay, so my MMF pattern will be, okay, if the field is like this, okay, field current, which is going to be DC current, is going to be IF. Okay, my MMF structure is going to be like this. MMF enclosed is going to be like this, because current enclosed is I, current enclosed is I, current enclosed is I, current enclosed is 0. Okay, so this is going to be MMF. Okay, now is it sinusoid? No. How to make it better sinusoid? For example, if I have rather than one slot per pole, let me have 3 slots per pole. Here also let me have currents. Here dot cross. Okay, actually, like, theoretical questions also they will give for 2 marks only in synchronous machine. Okay, because people are somehow scared of synchronous machine. Okay, so because of that, a theory question also can come for 2 marks. So that's why whatever is required for GATE 2020 I'm explaining. Okay, now if I keep that way, like, 3 slots are there. Three slots are there. Now in this, conductors are there. Okay, conductor currents are dot cross. Okay, now let us calculate MMF. So enclosed is going to be I, 2I, 3I, 2I, like that. So my MMF pattern is going to be field I. Here, if I add this 2I, if I add this 3I, 2I, I 0. Okay, so if you give this to Fourier harmonic component, sinusoidalness, okay, forget about harmonics and all. This is going to be non-sinusoid. This is also non-sinusoid, but compared to here, it is better sinusoid or not? Yes. Okay, so compared to this, it is going to be better sinusoid. So sinusoidalness of the field can be increased by having more slots per pole. Okay, so how to make field flux a bit better sinusoid in case of cylindrical rotor? Let us increase slots per pole in field winding should be more. This is going to be in field should be more. Okay, now let us think of salient rotor. How to make field flux more sinusoidal in salient? This is going to be salient rotor. Okay, in salient rotor structure will be like this. Okay, so in this salient rotor, okay, upon this stator will be there. Okay, how to make field flux a bit better sinusoid? Because if I can reduce harmonics in the field flux, in the stator, automatically induced voltage harmonics will be less. Because directly proportional to flux density, if flux density can be sinusoid, automatically induced voltage in a conductor will be sinusoid. Okay, now in this, what we do is, for example, if I think of this as stator, let me think of linearly. Now, if I have this constant air gap pole, okay, so then what will happen? For example, if I have n pole like this, my flux density, if you observe, okay, at the center of the pole, flux density will be more, at the pole tips, flux density will be less. But at the center of the pole, flux density is going to be flat topped. So it is going to be increase, almost constant, reduce. Okay, so flux density at the center is going to be more, maximum, but it will give flat top nature. So flux density, if you see here, given by the pole, my flux density, of course, this is stator, okay, my flux density is going to be increasing like this, almost constant, will be reducing like this. Okay, now let us change the pole structure. For example, if I can change the pole structure such that least air gap at the pole center and increase the air gap at the pole tips. Okay, so if I can maintain least air gap at the center, more air gap here, what will happen? What here at the pole tips, reluctance is increased or not? If reluctance is increased, my flux will try to flow through low reluctance path, such that previously here flux now will go through here, such that here at the pole tips flux density will be reduced, at the pole center flux density will be increased. So because of this, it will be reduced here, it will be increased here. It is becoming better sinusoid or not? Yes. So, in order to make field flux a bit better sinusoid, at the center of the pole, air gap should be least, and at the pole tips, air gap should be more, means that here, from here to here, air gap should be more, here also air gap should be more, at the center, air gap should be less. That is called as eccentric pole shoe structure. Okay, so by using eccentric pole shoe structure, we will try to make field flux better sinusoid in case of salient. And in case of cylindrical, this is cylindrical, no? Cylindrical rotor. In case of cylindrical rotor, okay, so in case of cylindrical rotor, by increasing number of slots per pole, we are going to increase the sinusoidalness of the field flux. Okay, now let us see mechanical things and electrical things, one thing let me tell you. If I ask people which machine, which generator you want to sell it, okay, somehow few people like salient because it is better, more complex, one thing, because people are scared of salient actually, and it will have some, on stability point of view also, it will add some reluctance torque and all, we will see at the end. Okay, so people say from stability point of view, let us use salient. No. Okay, everything has to be decided by mechanical engineer. For example, hydro plant is there. Okay, maybe let me take a small example here. Pelton wheel. Okay, Pelton wheel. Now upon Pelton wheel, let me throw stones. Okay, for example, if I throw stone here, which will rotate in this direction or not? Yes. Or I can have a flow of water here, or I can have a flow of gas here. Okay, for example, if this is the turbine blade, upon the turbine blade, if I if I release stone, okay, stone in the sense this is going to be solid, heat will be more upon the bucket. Okay, so upon the bucket, if stone is fallen down, it will rotate in this direction because of the stone, but because of the heat is more, it cannot be rotated at higher speeds, it will rotate at very low speeds. Of course, we don't have any stone kind of prime mover, but anyway, let us go to water. Now, if this is the bucket of Pelton wheel, for example, water is flowing like this. So speed of the rotation of the rotor can be more. Okay, in case of speed of the rotation of the rotor can be more in case of water compared to stone. If it is gas, steam engine, it's a gaseous form, so steam, it will spread very fast, it will be less. So steam engines will rotate at higher speeds. Steam engines or gas engines will rotate at higher speeds, and water turbines has to rotate at lesser speeds. Now, if something is rotating at lesser speed, which type of rotor has to be selected? If something has to be rotated at higher speed, which type of rotor has to be selected? We have to see. Okay. Now coming to here. Okay. What is the biggest advantage of cylindrical rotor? It is cylindrical, cylindrical rotor. Okay. So it is cylindrical rotor. Upon that stator is there, it is rotating. So natural airflow will not be there. For example, if you think of salient rotor, salient rotor is going to be, this is going to be salient rotor, okay. For example, upon the salient rotor, this is going to be stator. Now, if this rotor has to rotate in this direction, means that, for example, two-pole salient rotor means my stator is like this. So in this half section, air will be there. If it is rotating in this direction, this complete air has to flow like this. So because of this, one advantage is there, one disadvantage is there. Okay, the advantage is natural airflow will be there. So cooling requirements of the machine will be less. Okay, and second disadvantage is all air has to flow like this. Means that noise levels will be more if you try to rotate at higher speeds. Okay, windage losses will become tremendously high if you try to rotate this rotor at higher speeds. So this rotor has to be rotated at lesser speeds only. Okay, because of saliency, natural flow of air. Now if you think of cylindrical rotor, which is cylinder, upon that stator is also cylinder, smoothly it will rotate because natural flow of air will not be there, much will not be there. Okay, so my cylindrical rotor can be rotated at higher speeds, salient rotor has to be rotated at lesser speeds. So cylindrical rotor, higher speeds means that the cylindrical rotor can be used with higher speed prime mover. That higher speed prime mover is steam turbine. Now, this salient rotor has to be rotated at a lesser speeds only, otherwise noise levels will become tremendously high. So at lower speeds means that we can use this salient rotor with hydraulic engines, okay, hydro turbines. Now, coming to the electrical point of view, okay, see, if something if some rotor is there, okay, so which is rotated at 1 revolution in 1 second, for example. Now my rotor side is big, size is diameter is big. Now this is also rotating at same speed of 1 revolution per second. So here black revoluting 1 revolution per second, red revoluting 1 revolution per second, but radial velocity of red will be more because 2 pi r. Radial velocity more. So the moment radial velocity is more, automatically what will happen? Mechanical stress, centrifugal forces, mechanical stress will be more on the insulation. Okay. Now one advantage, let me tell you one thing. I say in the class also, the most costliest part of the machine is shaft. Because if you think of generator, prime mover. Now prime mover will try to rotate it in this direction, but generator has to have opposite torque. opposite are. In between these two shaft will be there, so that shaft mechanically should be so strong. Now in case of motor also, if this is motor is trying to rotate rotor in this direction, but load is trying to stop me. Okay, so in motor, what is load? If somebody is trying to stop my rotation, that is nothing but load in case of motor. So in motor or generator, mechanical stress will be more on the shaft. So shaft is going to be very costliest part, like cold forging methodology and all should be used. It is none of our business for time being. Okay, in detail we will see. Okay, now the moment length of the shaft, if you try to increase length of the shaft, cost of the machine will be increased. So in order to reduce length of the shaft, diameter of the machine should be increased. Because let me tell you one simple thing. Of course derivation can be derived, we will see in detailed machine. Volume of air in the air gap under the pole will give you the power handling capacity of the machine. Okay, so for example, means shaft length is increased. Shaft length is increased means that for the same power handling capacity, diameter will be reduced. If shaft length is reduced, for the same power handling capacity, diameter of the rotor has to be increased. Keep that point in mind. Okay, now coming to here, it has to be rotated at lesser speed only. It is rotating at lesser speed means that it is rotating at lesser speed means that I can increase the diameter such that mechanical stress, in order to meet the considered mechanical stress, anyway speed is less, so I'm going to increase this. If I increase this, automatically length of the shaft will be reduced. Okay, so in order to reduce length of the shaft means I'm going to increase diameter. of the rotor such that in this salient rotor machine, diameter is going to be big and length of the shaft is going to be less. Okay, that way. Now if you come to cylindrical rotor, in cylindrical rotor, it means it only can rotate at higher speeds means that it is used with steam engines. It is going to be rotated at higher speeds means that we have to prefer this, because speed is higher, mechanical stress cannot be more than a given value. So for any material of insulation, I can say, so the moment speed is more, we have to reduce diameter. If you reduce diameter, diameter is reduced, so length of the shaft should be more. So here the machine length will be more. Okay, so very simple. What is the conclusion here? Means salient rotor cannot be rotated at higher speeds, so speed should be less. If speed is less, centrifugal stress upon the insulation provided is going to be less only. So means I can increase the diameter such that length of the shaft will be reduced. Okay, cost of the machine can be reduced. But here, the moment speed is more, if I increase diameter, then what will happen? Centrifugal stress will be so high. So means for a given centrifugal force, if the speed is high, let us reduce the diameter, let us increase the length of the shaft. Okay, so means my steam engines or steam turbines connected alternator, we call it as turbo alternator, length of the shaft will be more, diameter will be less. In hydro generator, diameter will be big and length of the shaft will be less. Okay, now we have to add one more small point here. What is the frequency equal to P N by 120. Okay, so of course this derivation we did not consider, but anyway most of the members know that N equal to 120 F by P. We will see that in detailed course, okay, for 2021. Now coming to the point here, India is having frequency of all over India 50 Hz. Okay, so for a given frequency, if speed of the rotation is more, number of poles should be less. And means for a given frequency, if the speed is less, salient pole, if the speed is less, number of poles should be more. Now see here, in cylindrical rotor, for example, this is cylindrical rotor. Okay, in cylindrical rotor, diameter is less because it has to be rotated at higher speeds. Diameter is less. Okay, and number of slots per pole should be more in order to make field flux more sinusoidal. So slot should be there here, Okay, if you have more number of slots, per pole, you will get your field flux more and more sinusoidal. Okay, so diameter is going to be less, slots per pole should be more, so number of poles that can be incorporated in cylindrical rotor is less. That is okay for us because anyway cylindrical rotor is rotating at very high speeds. Number of poles that can be incorporated because number of slots per pole should be more in cylindrical rotor to make field flux more sinusoidal is less. So this is more, this is less, given frequency we can achieve, problem solved. Now coming to here. For example, if the speed is less, number of poles should be more. Okay, so in salient rotor, what we are going to do is, this is going to be the hub. We can keep pole here, 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 or if you want we can keep one more pole here, we can keep one more pole here, we can keep one more pole here, we can keep one more pole. Okay, so because basically my salient pole field winding is concentric in nature. Okay, in that way, because of concentric nature of the field winding, I can keep as many number of poles as I want. That too, diameter is big. Okay, so the moment diameter is big, automatically more number of poles can be incorporated. Okay, so more number of poles, less speed, same frequency can be attained. So conclusion is damn simple. Okay, what is the conclusion? Salient pole meant for hydro turbine, diameter is big. Yeah, what do you say? Active length or length of the shaft is going to be less. And cylindrical rotor, diameter should be less and length of the shaft should be more. Okay, it is supposed to maintain at higher speeds, means that turbo alternator or steam turbines we are going to use.